1.
Fractions!
Okay, very nice. Okay. All right, so we're going to talk.
Yeah. Fraction action.
So the last chapter was fairly extensive. We talked about solving every type of possible type of an equation with one variable, with the exception of when I taught the number word problems. I taught you equations with two variables. Remember that? Well, we're moving actually into two variables, and it's important to understand the difference between the two, because when I give you an equation with one variable, there is only one answer. Am I correct? Yep. Right? If I said, 2x plus 4 equals 10, I would subtract 4, and I have 2x is equal to 6. I divide by 2, and I got x equal to 3. And that is it! Whoa. There is nothing else that x can be.
We're done.
We're done. We're done.
Thanks for
Right? That's
lecture.
it. All right, end of lecture.
All right.
Okay.
That's it.
Just give us
So-
a ton of prose problems for homework.
Okay.
We'll get a
What about
So,
There are two answers.
true, with the exception of absolute value
And word problems.
and word problems. Okay, but if I give you one equation with one variable, there's a very specific answer. Don't you agree with me?
Yeah.
Right? Very specific.
Here.
However,
You're going to put 2, aren't you?
yes. So what if I gave you an equation where there are two unknowns, right? Y is equal to x plus 4. Do I know for sure what x and y are?
No.
Is there a way to know for sure what x and y are?
Unless you have
Unless it says y is this and x is that.
So I don't know what it is, right? I do know that if I said if x equals 0, then y equals what? 4, right? If x equals 10, then y equals
-6.
10. 10 plus 4. If, not y, I'm talking about x, okay? If x equals 10, then y is equal to 10 plus 4, which is 14, right? So, but I could keep going, right? I could say if x is a million, if x is a billion, if x is a trillion, if x is a quadrillion,
and
right?
4.
A sextillion, a septillion, all these things, right? I could keep going forever and ever. And then I haven't even started with the negatives. I could go the other way forever and ever in the negatives, right?
Please don't make us go forever.
So would you agree with me? Would you agree with me that there are an infinite number of possibilities for this, right? So what we're going to talk about today is how to graph these.
What?
Graphing these, that's pretty easy. On a number line, here's 0, 1, 2, 3. That's my answer,
Yeah, we're done.
right? We're done. But we're going to graph these that have an infinite number of answers, an infinite number of possibilities. And it's very useful. This is really used all the time in real life, right? It's very, very useful. Now, before we go there, we got to talk about a Cartesian plane. And my guess is most of you have been exposed to Cartesian planes, right? And graphing and points and stuff like that. And every year I say, okay, how many people understand how to plot points? And they all say, oh yeah, I get it, right? And they're so sure they get it, and they do, until I give them the homework, and then they do it all wrong. I don't know why. So just be sure you don't forget. So we're gonna talk about it for a second. So here we go. Right? So this is a Cartesian plane. And notice how many dimensions is this? Rosemary? Not quite. It's two-dimensional. We have an up, and we have a up and down, and then we have back and forth. Right?
Yep.
But it's a two-dimensional. This is a one-dimensional graph. This is a two-dimensional. I have two dimensions. I have the x dimension and I have the y dimension. Does that make sense?
Yes.
And so what I'm going to do is basically I've got to take both of them into consideration. I no longer am just going to have 3, right, to put on a line. I have to have something for the x and something for the y. And what I use is what I call a coordinate point. A coordinate point.
And
It's also called an ordered pair. So if you see either of these words, or these terms, those are the same thing. And it is written like this. You have a parenthesis, and then you have an x, a number that's in the x position, and then you have a number that's in the y position, and then you have a parenthesis.
so it's like coordinates.
And it's like coordinates. It is coordinates, right? And it tells you, it's like a map. It says first you do this, and x is going left or right, and y is going up or down. Okay? Does that make sense? And you are not done. You don't go to the x and then put a dot there, and then go to the y and then put a dot there. You're not done until you've done everything in this coordinate point. So if I said plot, well, let's just go over here for 1 second. Let me just draw a few little things here. And let's just, before I go into plotting points, let's just talk about this chart. Okay? And my guess is most of you know this, and it's probably review. But you're going to learn, maybe not today, but very soon you're going to learn some very cool stuff. Very cool stuff. I love graphing. I love it. And then I start doing whiteboards with you guys where I give you 10 seconds or less to graph an equation. And you get so good at it. It's amazing. All right? So, first of all, we have the y-axis. This is called the y-axis.
And the x.
And this is called the x-axis. All right? And some people have trouble remembering that. I don't know why, but maybe just because they're not used to it or something. But on a map, on a treasure map, somewhere on the ground, the treasure's buried, and what marks the treasure being buried there? An X, right? So the X is on the ground, right? It goes back and forth. And what creature rhymes with Y?
Fly.
What? Yes, fly. A fly, right? Flies go up and down, right? And all around.
Go to the side.
Right?
Gary, they land on the ground.
Flies never go left and right. They go like that.
Our 6th teacher taught us a simple rhyme.
So Sienna's got a cool rhyme.
It's just a simple rhyme. It goes, it's just X,
Wait,
Y.
I'm sorry. Wait. I'm sorry. Rico, listen. Go ahead.
It's just X, Y, walk, fly.
X, Y, walk, fly. X, let's try it. X, Y, walk, fly. All right, very nice. I like that. X, Y, walk, fly. Beautiful. We'll use that. What is this point called?
Wait,
Zero. Zero.
The origin point.
It's called the origin. Right there at 0, 0, that is called the origin.
The
Right
starting
there,
is the birth
that's
place.
the origin. And, all right, let's talk about another thing. There are 4 quadrants. There are 4 quadrants to a quadratic plane. Okay? Quadrant 1 is kind of weird. It's not kind of where I would have thought intuitively. That's quadrant 1. Right? And it's always written in a Roman numeral. I'm sorry, Luke, can you move over here, buddy? It's just you're talking way too much to Rico. But go around that way, not through the video. So you always write your quadrants in a Roman numeral, uppercase Roman numeral, right? And then this is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay? And notice, this is going to be, if we just make these all 1 unit. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay? Going up from 0, from the origin, it's all positive, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Going down is negative. That's -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay? So if I gave you a point like this, 2, 5,
Got it.
what quadrant would that be in? Sienna.
1.
Quadrant 1. Let's just think about it. That says, let's use our let's follow our map, basically. It says, I go to the right 2. I go to the right because 2 is positive. If 2 was negative, I'd go to the left, right?
Yep.
So I go to the right 2, but I don't put a dot yet. I've got to go up 5. So I go to the right 2 and up 5, and I put a dot. Yes! That is in quadrant 1. What if, so what is quadrant 1 in terms of signs? What would quadrant 1 be? What would x and y both be? Positive, positive. So I know quadrant 1 is always positive, comma, positive. Does that
Gary.
make sense? You guys see what I'm saying?
Gary.
Yes.
Never mind.
Okay, if you think about it, just raise your hand again. So what if
It's obvious.
what if I asked you to do this? -4, 1. What quadrant would that be in, Brisa?
2.
So it would be 2. Okay, let's try it. -4. Remember, we walk before we fly, right? We walk before we fly. So we're going to go -4 to the left, and then we got to go up 1, dot, right? So that is clearly in quadrant 2. That's right. So what are the signs of quadrant 2?
Negative, positive.
Negative, positive. Exactly. Negative, comma, positive.
And then on the bottom it's the up. Well, and
All right, what's the signs on this one?
negative, negative.
Negative, negative.
And then it's positive, negative.
And then this is positive, negative, right? Okay, good. So let's say I gave you 6, -3. What would that be?
It would be
Rosemary.
I believe it would be in number
Yes. So I go over 6 and I go down -3 and then I put a dot. Okay? What if I gave you -2, -2? What quadrant would that be in? Dan. -2, 3. Yes. -2, -2. Oh, it's right in the middle of my origin.
Gary.
Oh, why did I do that? Oh well.
Gary, can I ask you a
There
question?
it is. Yeah.
Because this stuff is really easy, and I
Yes.
can do this in like 5 seconds.
Yes.
Are we gonna do more complicated stuff, or is it just this for now?
Oh, yeah. I'm just introducing. I'm introducing this stuff. I want to be sure that we're all on this page, this way, that we understand this part first. This to 5. How many people get this? How many people already knew this? All right, awesome. That's great. So I don't have to spend too much time on this. So let me think if there's anything else I need to talk about.
No, I think you're good to hand out the whole.
I think that's good.
I think it's gonna get more complicated.
Yeah, we're not done yet. We're not done. The lecture's not done, guys. Now we're moving. Now we're going to graph. Now we're going to graph an equation. Okay? Right? But we couldn't graph an equation until I knew that everybody understood a coordinate plane. Right? So now that we understand it, I'm going to just erase all this, and I'm going to assume you guys know the positives and negatives and all those things.
Yep.
And I'm going to assume you know that's the origin. I'm going to get rid of that little dot there. Okay? And here we go.
Wait, I'm not ready.
Gary, usually.
There is a method. When I give you an equation with two unknowns, right? Like y equals something x plus something, right? Then you're going to use a t-chart. How many people have been exposed to t-charts? Half of you, or maybe not even half.
I
Okay.
don't know.
All right. So I think you'll see. You may or may not know them, but I'm sure you will all find them very easy. They're really quite easy to do. The beauty of a T-chart is you can graph anything with a T-chart. Anything. I am going to teach you all these shortcuts on graphing. Is that clear? I'm going to teach you, just like I taught you all these tools for solving equations. I'm going to teach you all these tools for graphing so that you can graph something that with a T-chart might take you about a minute or a minute and a half. With the shortcuts, will take you 4 seconds. Right? Literally. And so these shortcuts are powerful. But if you're on a test, if you're taking a test and you forget the shortcut and you can't remember, oh, wait a minute, which form is that equation in? What can you always do? You can use a T-chart. All right? T-charts always work. Okay? Okay. So here we go. Let's say I gave you y is equal to, we'll start simple. X minus 5. Okay? Here we go. So this is what a T-chart looks like. You put an X and a Y, and you draw a line between it, and you put a T right there. So it's like a T. That's why they call it a T-chart. In books don't like these because books don't like to use so much vertical space. So books do this, right? You don't have to write this down, but they'll put an X here and a Y here. And they do a horizontal chart. I don't know what you call it, but it's a T-chart, basically, right? There's a T, a sideways T. But these are so much quicker to do, so much easier, right? And there's another beauty of this. Once you've got your X, when you say your X and your Y, once you figure that out, that is your coordinate point. It's already in the coordinate point. It's already in your parenthesis X, comma, Y, parenthesis format. It just doesn't have the parentheses, but it's in the right X, comma, Y. So that's your point, right? And that's your map to go to that point. So now, one thing before I go into this, X, is this on the, X is my independent variable. Independent variable. So write that down, that's really important. Y is my dependent variable. Okay. Can anybody explain to me what that might mean? Anybody have any ideas? What does dependent and independent mean? Gardner.
So, I'm not really totally sure, but I think it means that you couldn't solve for y if you didn't have x.
Exactly. And so, exactly. You can't solve for y unless you know what x is. Does that make sense? So, and we are going to choose x completely independent of y. We get to choose anything we want for x. Does that make sense?
Yeah.
We get to choose the x's, and then we figure out what is y when x are those things, right? That's why x is totally independent. It doesn't care what y is. Y is totally dependent on what we choose for x. Does that make sense? You see the difference? Okay. Now, we're going to choose how many points do you need to draw a straight line?
3.
You only need 2 points. Am I right?
Yeah.
Okay. How many points are you going to have in this? How many x's are you going to choose? Why 3, Jan? Why 3? You're right. I agree with you. But why?
Because it's special.
Careful, guys. Careful. Ah. Careful. I'm sorry, what?
Because 3 is special.
3 is special.
These are special snowflakes.
Right, okay. Rosemary.
Because there's already an X.
No. Why would, it's sort of a safety thing. Why would you choose, when you only need 2, why would you choose 3? So basic, do you have an idea?
Because there's 3 things up there. There's an X, a Y, and a negative 5.
No, but look, can you
Because 3 is more than 2.
Can you draw a straight line between those 2 points?
Yes.
Right?
Yes, you can.
So if my third point was right here, then I would feel pretty confident I got it right. Don't you agree with me? But what if I did a point here, and a point here?
Try
Well,
it.
that's
Well, wait a minute. Which do I connect these two, or do I connect these two, or do I connect these two? Do you see what I'm saying? So what does that mean when they come like that? When they're all over the place?
You're wrong.
It means you're wrong somewhere, right? So by having 3 points, it's very unlikely to do 3 points wrong all in a straight line, right? Very unlikely. Does that make sense? And so if you see that they're not in a straight line, then you go back to your T-chart and see which place did you mess up, right? You just check it, right? So is that a, what is that, buddy? What is that? Okay, can you just put it away? Okay, so you're going to choose 3 points. And when you're dealing with a straight line, you choose 3 easy points. You don't go negative 45, 279, and 2,463, right? That would be a bummer, right? That would be a bummer to grab. So the first one you always choose a 0.
Not really. You could choose 1.
Always choose 0, just to get touch. Trust me, it's a good. You can choose anything, but I'm suggesting the easiest method.
No, technically you're telling us to just say always choose. It's not very suggestive.
Thank you. You're right. So 0, always choose 0. The next one, most often choose 1, and most often choose 2. 0, 1, and 2. Maybe 80% of the time, those are going to be great for you.
I don't like those numbers, Gary.
I know, there's a 20%. There's
Where's
something
that
else.
20%, Gary?
I don't think I'm going to go into that today,
The
though.
20% is just you.
So we have now chosen our independent variables. You agree with me?
Yes.
So let's figure out what our y is. When x is 0, I'm going to just bring the 0 up here. I'm going to substitute it in. I've got y is equal to 0 minus 5. Y is negative 5. All right, when x is 1, y is 1 minus 5. Negative 4. When x is 2, 2 minus 5. Negative 3. Now these are points. These are coordinate points. I don't have to do this. I don't have to do that. Because that's already, see, 0's first, negative 5 second. I'll just go. I start at my origin, always. And then I go nowhere, right and left. And then I go negative 5. So I'm going to go down to negative 5 and put a dot. Then I go over 1. From 0, 0, I go to 1, and I go down 4, put a dot. And then 2, negative 3. From 0, 0, I go over to 2, and I go down negative 3. About there, right? Do they look like they're a straight line?
Yeah.
Yes. So I bet you I did it right. So now I can.
Wait, Gary, can you do that one more time and do the problem just so I can see it again? The camera's in my way a little.
Oh, I'm sorry.
I just
So I plotted these, right? So I went 0, negative 5. So 0, I start at 0, 0 at the origin, and I don't go anywhere. I go 0 left and right, right? And then I go down negative 5 to there. And I put a dot then. And then 1, negative 4. 1, negative 4, dot.
I totally get it now.
2, negative 3, dot. Okay, so now I just draw my line. I have my straight line. And why would I put arrows?
Because otherwise it's a line segment.
So, but yeah, so Lucas.
Okay, because it theoretically could go on forever. You could get negative, or you could choose negative 500, and it would still work. So yeah, there's infinite
Right.
number of ways to get it. So
Exactly.
you have to put arrows.
All right,
Exactly. So this equation has an infinite number of solutions. Your graph has to show that it has an infinite number of solutions. Jan was right. If you don't put the arrows, it's called a line segment, right?
Yeah.
You guys know that?
Yes.
Line segment, right? So this line goes on forever and ever. So that's basically it. Let's do one more really fast.
Can I try doing it here? Can we all do it together?
Wait, Gary.
No, we're gonna do this. We're just going to do this really fast because
Gary,
yeah.
to graph a line is impossible because a line has 0 points.
You can,
It never starts and it never stops.
I know, but it's not starting, it's just setting up
It's not
the order.
starting.
Yeah, that's why there are the arrows. Because
Yeah.
Are you going to be my troublemaker? Is that to 3x minus 4. Why is it equal to 3x minus 4?
Why is negative 4?
When x is 0, 3 times 0 is nothing. So y is equal to
Minus 4 is
negative 4. When x is 1, 3 times
Negative 1.
negative 1, right? You guys can see what it is? Because 3 times 1 is 3. 3 minus 4 is negative 1. So I put negative 1. And when x is 2, 3 times 2 is 6. Minus 4 is 2. So there are my 3 points. So I'm going to plot them. 0, negative 4, dot. 1, negative 1, dot. 2, 2, dot. Does that look like it's a straight line?
Yeah.
It does. So now I just draw my straight line, I put arrows on the end, and I'm done.
Overtime.
Okay.
Overtime.
Right. Are there, before I turn this off, are there any questions?
No.
Awesome.
No.
Great.
Gary, the question that you just asked us was the question.
This thing got moved. Okay.